This is Mr. S, and I want to welcome you back to World Geography, Unit 1, Lesson 2. We're going to start talking about the tools a geographer might use. Specifically, we'll be talking about maps. A very basic definition for map is a drawing of all or parts of Earth's surface. But as you'll soon see, there's much more to maps than that. The job of a map is to show the location of a place or thing on Earth's surface. This location can be shown in one of two ways. The absolute location, or the exact place on Earth where something is located. An example might be your street address. If you live at 100 North Main Street, then that is the absolute location of your home. There's also a grid system that can be used to show absolute location of a place. We'll talk about that in a moment. The second way that location can be shown is with relative location, where a place is located in relation to another place. Relative location is a more broad idea. For example, if you live in Arizona, you might say that you live in the southwestern part of the USA. This is a great way of describing location when precision isn't quite as important. Nearly all maps suffer from one big problem. They're flat, but the Earth is a sphere. How can you accurately show the surface of a sphere on a flat piece of paper? An activity that you complete at home is to get yourself an orange and try to peel the skin off all in one large piece. Then you should try to lay that piece of orange peel out flat on your table. You can see that it doesn't lay out well, and it isn't a neat rectangle like most maps. The way that geographers have tried to solve this problem is by creating different map projections. All map projections show at least some distortion of the image on the map. Distortion is a change in the shape, size, or position of a place when it's displayed on a map. Some map projections distort things differently than others. We'll spend the next part of this video going over some of the most common map projections and talking about their strengths and weaknesses. Here we see a map shown in the azimuthal projection. It shows the North and South Pole as the center point. This map is popular for viewing the poles because it shows them in their entirety and in their true shape, unlike most other projections. There's very little distortion in the center of the map, but the distortion is quite extreme toward the outer edges. This can be seen when looking at the Eurasian landmass. It appears to stretch nearly halfway around the globe, which is quite an exaggeration. The next map projection is the Mercator projection. It was created by Gerardus Mercator in 1569. Imagine that you had this map printed on a piece of paper and you rolled it up so that the left and right edge were touching. What shape would you have? Your map would be the shape of a cylinder, or like a wrapping paper tube. This explains why things near the top and bottom show extreme distortion. This map makes Antarctica look like it's bigger than all the other land masses combined, when in reality, it's only barely larger than the United States. It also shows that Greenland and Africa are a similar size, when in reality, Africa is more than 10 times larger than Greenland. When this map was made, the Mercator map was popular because ships were still the main mode of transportation on the ocean, and this map shows directions accurately. It was well suited to navigating during these times. It's still a very popular map projection because it generally shows things in their correct shape and relation to one another, although their size is very distorted. The Robinson projection was created in the 1960s by geography professor Arthur Robinson. It's similar to the Mercator projection, but its creator attempted to reduce the amount of distortion shown. Notice how the top and bottom seem to be pinched in. This was an attempt to make it so that places like Antarctica weren't quite so large. It certainly isn't perfect, but it does make the distortion somewhat less severe. There are dozens of other map projections, and we'll discuss some of them later on in the course, when they're applicable. But the ones I've spoken about here are among the most common and are the ones that we'll use most often throughout this course. When looking at a map, you will almost always see a few common features. The first of these is the title, which simply tells you what the map is showing. The next is the compass rose, which is an icon that indicates directions on the map. A compass rose will always show you cardinal directions, and sometimes it'll show you intermediate directions. Cardinal directions is simply north, south, east, and west. Intermediate directions are the lines that fall between cardinal directions, northeast, northwest, southeast, southwest. The next common map feature is the legend, or the key. Maps often have small symbols on them, and the map legend will tell you what those small symbols mean. For example, a star often means a capital city. On nearly all maps, you'll find a map scale. This shows you distance. It might show you that 1 inch on a map equals 10 miles in real life. Every scale is different though, so it's important to always look at the scale. Another common feature of a world map, or a map of a large area, will be the lines of latitude and longitude. Latitude and longitude is a numeric system that you can combine into a coordinate to indicate absolute location. Lines of latitude are imaginary lines that run east and west around the world like a belt. An easy way to remember that latitude runs east and west is because they will look flat on a map. Latitude, flatitude. Latitude lines always run parallel to one another and never intersect. Lines of longitude run north and south. All lines of longitude intersect. They always intersect at the North Pole and the South Pole. You see how the latitude lines on this map don't ever begin to move toward one another? Now notice the longitude lines. As you get closer to the top and bottom of the map, we can see that they are moving toward one another and will all meet at the North and South Pole. Latitude and longitude lines are all assigned a number of degrees. The centermost line of latitude is called the equator. The equator is 0 degrees latitude. As you move north from the equator, the latitude lines increase. 10 degrees north, 25 degrees north, 88 degrees north, and so on up to 90 degrees. As you move south, the same thing happens. 10 degrees south, 25 degrees south, 88 degrees south. The Earth is divided into a northern and southern hemisphere, or half of the globe. The dividing line between those hemispheres is the equator, 0 degrees latitude. That's why lines north of the equator are labeled 10 degrees north, 25 degrees north, while lines south are labeled south. Longitude is no different except that they are labeled east and west. 0 degrees longitude is called the prime meridian. It runs through Greenwich, England. If you travel east from there, the lines are numbered like the lines of latitude are, except it will be 10 degrees east, 53 degrees east, 125 degrees east, all the way up to 180 degrees, which is the line on the opposite side of the globe from the prime meridian. If you travel west from the prime meridian, your numbers go up 10 degrees west, 53 degrees west, 125 degrees west, and so on. And again, this will end at 180 degrees on the opposite side of the globe. Much like lines of latitude, the prime meridian divides the Earth into an east and west hemisphere. That's why the lines east of the prime meridian are 10 degrees east, and the lines west are 53 degrees west. Every place on Earth is in 2 hemispheres. New York City, for example, is north of the equator, so it's in the northern hemisphere. It's also west of the prime meridian, so it's in the western hemisphere as well. Using this system of imaginary lines and numbers, you can place an absolute location on anything in the world. Your refrigerator at home could be located using this system. To do so, you find the exact line of latitude, then the exact line of longitude. You pair these numbers up and it gives you a coordinate, which is an absolute location. For example, Phoenix, Arizona is located at 33 degrees north and 112 degrees west. Okay, we've talked about a lot of maps today. We discussed why maps look the way that they do and the information that maps have on them. In our next video, we'll talk about different maps and how they're used. Don't forget to like and subscribe so that you don't miss the next lesson as it's posted. Thanks so much, and I'll see you next time.